Section 9.7. Diagonal bifid. A variation on the bifid cipher is to write the Polybius coordinates vertically under each letter, as usual, but to read them out diagonally, going from lower left to upper right, or southwest to northeast. This is called a left diagonal or an anti-diagonal. On a heraldic crest, it is called bar sinister and indicates out-of-wedlock birth. For the last letter, you wrap to the first column the shaded digit 1. The advantage of this is that there are no naturals or half-naturals to help Emily guess words. Here is an example. Diagonal bifid is rated 4. With conjugated matrices it is rated 5. With conjugated matrices and periodically varying block sizes it is rated 6. Unlike classical bifid, both odd and even block sizes can be used with diagonal bifid. Section 9.8. 6 by 6 squares. If your messages contain a lot of numbers, it may be advantageous to use a 6 by 6 Polybius square instead of a 5 by 5 square. A 6 by 6 square allows you to have the full 26-letter alphabet plus the numerals from 0 to 9. There is no need to omit J or Q from the alphabet. If you are enciphering by hand, this requires taking extra care to distinguish the letters O, I, Z, S and G from the digits 0, 1, 2, 5 and 6. Some people adopt special conventions, such as underlining all digits. I find this cumbersome and error-prone. I usually just exaggerate the characteristics that distinguish each of these characters from its mate, such as writing the letter I with extra wide serifs. All of the methods from the preceding 5 sections, namely Playfair, 2 square, 3 square, 4 square and bifid, can be used with 6 by 6 squares, along with all of their variations. Section 9.9. Trifid. If you like squares, how about cubes? Another fractionation method, also invented by Félix Marie Delestel in the 1890s, is the trifid cipher. Instead of representing each letter of the alphabet by 2 digits in base 5, quinary numbers, each letter is represented by 3 base 3 digits, ternary numbers. This gives 3 times 3 times 3, or 3 to the power of 3, different 3-digit combinations. This is enough for all 26 letters of the alphabet plus 1 extra character. Delestel used a plus sign for the 27th character. The extra character, plus, may be used as a form of punctuation, or it might be a signal that the following plain text letter should be interpreted as a digit. The correspondence plus A equals 1, plus B equals 2, plus J equals 0 could be used. The rest of the alphabet could also be used as special characters. For example, plus K could mean period, plus L could mean comma, and so forth. Just as the 2-digit combinations can be displayed as a 5 by 5 letter square, the 3-digit combinations can be displayed as a 3 by 3 by 3 letter cube. The 3 digits in each triple can be interpreted as the coordinates in the cube where that letter is located. These coordinates are commonly called the layer, the row, and the column. Here are the 27 ternary combinations, in order, with letter equivalents, weakly mixed by using the keyword example and alternating columns. For instance, the letter N is represented by the triple 1, 0, 2, so it would be located on layer 1, row 0 and column 2 of the 3 by 3 by 3 letter cube. The trifid cipher works similarly to the bifid cipher. The plain text is written in blocks of some fixed size. The size may be any number that is not a multiple of 3. The 3 digits are written vertically beneath each letter of the message and then read out horizontally in groups of 3. Then they are converted back into letters using the same equivalences. Here is an example with the plain text "Send help" and block size 4. The same analysis and techniques that were used for bifid can also be applied to trifid, and they have the same ratings. You can use two separate substitution tables for converting the letters to digits and the digits back to letters. You can vary the block sizes. You can start reading out the digits from different places in each block. You can use a strong transposition to mix the ternary digits. A natural question is whether there is a diagonal version of the trifid cipher, analogous to diagonal bifid. The advantage of diagonal bifid over the original bifid is that the diagonal version does not give rise to the half-naturals that weaken the original version. In the analogous diagonal trifid, the middle digit of every group would be a third natural, so the advantage is lost. The problem of naturals disappears, though, if you use two different mixed alphabets, one for writing in the digits and another for reading them out. Diagonal trifid with two alphabets is rated 5. Section 9.10. 3 cube. As I was typing the preceding paragraph about the trifid cipher, I realized that the 3 by 3 by 3 cubic arrangement lends itself to a three-dimensional analogue of the two-square cipher described in section 9.3. It is easy to visualize the two-square cipher in 2 dimensions, but harder to visualize a cube in 3 dimensions, so I'm going to describe the new cipher solely in terms of the coordinates. Let's call this cipher 3 cube. Two-square enciphers 2 letters at a time using 2 substitution tables. Ergo, 3 cube will encipher 3 letters at a time using 3 substitution tables. Here is a set of 3 tables, well mixed using the keywords Columbia, Stanford, and Hopkins. These 3 substitution tables are designated S, T, and U. That's S for substitution, T for table, and U for the next letter in the alphabet. The substitution tables correspond the 26 letters of the alphabet and the character plus with the 27 ternary triplets. Like trifid, 3 cube begins by writing the 3-digit triplet for each letter vertically beneath it. The 3 digits for the first letter are taken from substitution table S, the 3 digits for the second letter are taken from table T, and the 3 digits for the third letter are taken from U. The pattern is shown here and illustrated by the trigram fly. Then the digits are read out left to right, and these horizontal triplets are converted back to letters. It would seem natural to use table S for converting the top row, table T for the middle row, and table U for the bottom row. However, that would lead to a 1 in 9 chance that the top row would be identical to the left column, so that the first plain text letter would be replaced by itself. That is, there is 1 chance in 9 that S1, S2, S3 is the same as S1, T1, U1. The same is true for the middle and bottom rows. Let's call this situation, where 1 digit is the same, a part natural. For this reason, substitution table S is used for the second row, table T is used for the third row, and table U is used for the top row. This eliminates the naturals. Here is the pattern. Since this is hard to keep straight when you are enciphering by hand, I suggest writing the choice of substitution table over each triplet of digits. This is similar to writing the key letter over each plain text letter when using the Belasso cipher, section 5.5. Here is an example of 3 cube using the plain text message Fly to Rome. The 3 cube cipher is rated 7. There is a simple way to strengthen the 3 cube cipher. Instead of converting the triplets back to letters using the 3 substitution tables in strict rotation as we just did, use a key to set the order of the readout tables. The key would consist of the letters S, T and U in some scrambled order, for example SUTUTTUUSTS. The length of this key should not be a multiple of 3. I call this variant 3 cube plus. Here is how Fly to Rome would be enciphered using this readout key. Using 3 cube plus, about 1/3 of the letters will have part naturals. That is, one of the 3 write-in digits will be the same as one of the readout digits. However, Emily will not know which letters have this defect and will not be able to exploit it. 3 cube plus is rated 9. So, you might well be saying, is it possible to nudge the rating up to 10 without making the cipher too complex for hand use? Thank you for asking. First off, let's increase the number of substitution tables from 3 to 6. Let's call them S, T, U, V, W and X. Instead of writing in the triplets using a strict rotation STU, 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 we will use another letter key consisting of those 6 letters in some scrambled order. The write-in key could be TWXUSTTVWV, and the readout key could be VWTXXSUSVTU. Ideally, the lengths of these keys would be mutually prime, and neither length would be divisible by 3. Here the lengths are 10 and 11. Let's call this cipher 3 cube super. This is an example of 3 cube super using the plain text Fly to New York. 3 cube super is rated 10. This is another unbreakable hand cipher.